Hi, how are you? Okay, so today we are going to talk about the elements. Elements, compounds, and of course, the periodic table. So let's look, for example, the first one, elements. Okay, an element is a pure substance that cannot be separated into simpler substances by physical or chemical means. On Earth, over 90 elements occurs naturally. For example, copper, oxygen, and gold. Okay, we have three different elements. So let's look. I could share with you my screen, okay? So, for example, copper. Okay, we use copper for electronic devices, okay? Um, for example, wires to conduct electricity. Yeah, but copper, you can find copper on nature at different minerals, okay? For example, the chalcopyrite or the malachite or the bornite, for example, we have on the screen. And uses copper's use can be on, of course, electrical wires, or for example, uh, to do the Statue of Liberty, okay? At New York City, for example, okay? A brass trumpet or a bronze helmet, we can see different application of copper. Oxygen, okay, if we look oxygen, okay, oxygen is the principal element, for example, that humans, animals, and plants, of course, use to live. Plants uses oxygen for do its photosynthesis, for example, okay. Inside the car, motors use oxygen to do that combustion reaction to burn the gasoline, okay, and that made, for example, that the car can move. And water is compound of oxygens atom, okay. So look at this, oxygen is very important for us. And gold, okay, let me see, okay. Oh, silver, of course, this will be another element. There it is, gold, okay. Look at its shiny appearance, okay. Gold, for example, of course, you can find gold on different minerals. We use gold like a currency, or use gold for jewelry, okay. So, for example, an ancient gold jewelry is made of gold. Actually, astronauts visor has a very thin layer of gold and protects the astronaut from the sun heat, for example, okay? Excellent. So copper, oxygen, and gold are naturally occurring elements, but also are several elements that do not exist naturally, but have been developed by scientists. Okay, on this list we can mention, for example, let me see. Oh, for example, boron. Okay, boron is an artificial element named after the Danish scientist Niels Bohr. This was to honor his model of the structure of atoms' electron shells. Okay, so that is an artificial element. Okay, so on a periodic table we can find natural and artificial elements. Each element has a unique chemical name and chemical symbol. The chemical symbol consists of 1, 2, or 3 letters. The first letter is always capitalized, and remaining letters are always lowercase. For example, iron. Okay, that will be an F and an E. Okay. The naturally occurring elements are not equally abundant. For example, to make up approximately 75% of the mass of the universe, oxygen and silicon together comprise almost 75% of the mass of Earth crust, while oxygen, carbon, and hydrogen account for more than 90% of the human body. Francium, okay, on the other hand, is one of the least abundant naturally occurring elements. There is probably less than 20 grams of francium dispersed throughout Earth crust. So we have here two different elements with a significant difference of percentage of its abundance on Earth. Okay. So first, let's look the periodic table. Okay. So over the 65 years of the 19th century, a bewildering variety of new chemical elements were discovered, many of them rare and obscure metals, but also substances that are well known today, such as silicon and aluminum. By 1866, a total of 63 elements were known, but although these fell into a few obvious categories, such as metals and non-metals, overall, there seemed to be no rhyme or reason of them. In short, chemists at the time were in desperate need of a new way of understanding and classifying the elements. And by early 1869, a Russian chemist, Dmitry Mendeleev, had been trying to make sense of the elements for some months. He wondered whether if they were ordered by their atomic weight or in some other way a pattern might emerge. On February day, he became so engrossed with the problem that he canceled all engagements and began writing down the names of the elements on the backs of playing cards. Okay, So this little guy was a little genius. Okay, I will show you a picture. Okay, there it is. And he tried arranging the cards with the elements ordered by atomic weight in a grid of rows and columns. There seemed to be some periodicity or recurring pattern to the elements, but also many misalignments. So there is a picture of Dmitry Mendeleev and the first periodic table in history. Okay. Dmitry Mendeleev, well, was a Russian, okay, a Russian chemist, and of course an inventor. He formulated the periodic law, created a far-sighted version of the periodic table of elements, and used it to correct the properties of some already discovered elements, and also to predict the properties of 8 elements yet to be discovered. In 1863, there were 56 known elements, with a new element being discovered at a rate of approximately 1 per year. Other scientists had previously identified periodicity of elements. So for example, John Newlands discovered a law of octaves, noting their periodicity according to relative atomic weight. His proposal identified the potential for a new element, such as germanium. Okay, the concept was criticized, and his innovation was not recognized by the Society of Chemists until 1887. Another person to propose a periodic table was Lothar Meyer, who published a paper in 1864 describing 28 elements classified by their valence, but with no prediction of new elements. So why is he great? Of course, Mendeleev. Is it because he lists down the known elements? No. Besides, he wasn't even the first person to do it. Is it because he arranged elements with similar properties together? No. That had also already been done too. Okay? So the periodic table that Mendeleev did is mainly based on 2 facts. 1, atomic mass. 2, similarity of chemical properties. Mendeleev's periodic law said that the physical and chemical properties of elements are the periodic function of their atomic masses. Okay? And of course, you have to know this. Each atom of every element in the periodic table, each atom has electrons, protons, and neutrons, okay? And the different quantities of these 3 particles inside an atom define the atom, okay? So for example, at hydrogen, we can find 1 proton and 1 electron. But for example, in oxygen's atom, we can find 8 electrons, 8 protons, and almost 9 neutrons. But we're going to talk about this later. Okay. So predication of elements. If you observe the third column and the fifth row, you will observe a dash, okay? That dash there proves his genius. He made a very bold statement here. We all haven't discovered this element yet. In the meantime, I am going to give it a name, okay? It is one step for aluminum, so I will call it Eka aluminum, Mendeleev said, okay? And look at this, yeah, this is very important. The element on this particular year doesn't exist, right? So he called it Eka aluminum, okay? Eka aluminum, okay, nobody found Eka aluminum yet, so we don't know anything about it, right? Run. Yeah, run. Why run? Okay, based on where it is located, I can tell you about it. So that said Mendeleev. Later, he made a few conclusions about aluminum, he said. For example, the atomic weight is 68. It's a solid metal, lustrous, heat conductivity, malleable and ductile, for example, a melting point low, and a cubic centimeter weighs by 6 grams. Okay, all of them are aluminum characteristics. So a wrong order of elements, he basically arranged the elements according to their masses, but sometimes place a lighter element before a heavier wants to satisfy that all elements in the column have similar properties. Let's look this. So for example, in reality, nickel weighs less than cobalt, but Mendeleev has placed cobalt before nickel, okay? At the first periodic table that he wrote, okay? So limitations of this periodic table is the position of the hydrogen, okay? So hydrogen has been placed with the first group with the alkali metals. Hydrogen makes compounds just like the alkali metals, but also has a diatomic molecule, like, for example, halogens. Mendeleev could not explain about this anomaly. And the second are the isotopes, okay? Mendeleev could not give separate position for the isotope of an element. And the principal example for isotopes will be the hydrogen. Okay, look at this. This is very strange, but I know, but at the beginning, it's like that. For example, hydrogen, it has only one proton and one electron, right? Okay, that will be hydrogen on the periodic table. There is no neutron, okay? But if we aggregate a neutron, we form an isotope, okay? The deuterium. The deuterium has one proton, one electron, and one neutron, okay? And yeah, let's do a crazy thing, okay? Let's aggregate another neutron. Okay, now we have two neutrons, one proton, and one electron, okay? Now we form another isotope, and there is tritium, okay? isotopes are atoms with different amount of neutrons, okay, from the neutral atom that we have on the periodic table. So the principal atom in the case of hydrogen is the first one, the red one, yeah? Okay, one proton, one electron, and that's it. We aggregate one neutron, okay, there is a side, we form an isotope, is deuterium. And if we aggregate another neutron, okay, poof, there is an isotope, another isotope, and it will form tritium. Okay, so the organization of the periodic table, we can find, for example, okay, a periodic means, okay, and this happen at regular intervals, okay? So arranged in increasing atomic mass and atomic number, okay? We can find on periodic table periods that are the horizontal rows of elements and same number of energy levels for electrons, okay? We can define these periods like horizontal rows, okay? And groups or families are the vertical column of elements and share chemical properties and the same number of valence electrons. That I will talk about this later. Yeah, just you have to know that and groups, all elements that belongs to a particular group has the same number of valence electrons, okay? So, this is very important. I will share my paper here, okay? So, look at this. At the midst of this effort, yeah, of course, of Mendeleev, he fell asleep, and while dreaming of playing patience, an idea came to him. What if spaces were left in his grid for elements that were undiscovered? Remember, the ECA aluminum. When he awoke, Mendeleev found that a few adjustments to this grid produced a layout that worked brilliantly to show the relationships between all the known elements. The first version of the periodic table had been born. The periodic table organizes the elements into a grid of horizontal rows called periods and vertical columns called groups or families. The table is called periodic because the pattern of similar properties repeats from period to period. That's the reason why we call periodic table, right? Very good. So, that is the organization of the periodic table. So, verticals groups, okay, look at this. Each vertical line has its own color, yeah? And the periods are the horizontal rows, okay? The periodic law, the repeating chemical and physical properties of elements change periodically with the element atomic number. So remember that the basics of atomic structures are as follows, okay? Protons are positively charged particles. weighing 1 atomic mass unit and located in the nucleus. Also, neutrons are located in nucleus, sorry, and are naturally neutral charged particles, weighing approximately 1 atomic mass unit and located, okay, I'm located in the nucleus, I said that. And the third particle are electrons that are negative charged particles weighing 0 atomic mass unit and located in the various orbitals of the energy levels outside the atomic nucleus. Okay, just protons and neutrons are inside the nucleus, and electrons are located on different orbitals around the nucleus. Okay, so we have here the weight of an electron, for example. Okay, and it's so tiny that it would take about 1,830 electrons to equal the mass of one proton. Okay, that's amazing. Okay, at the periodic table, we can find metals, non-metals, and metallics. Okay, so let's talk about metals. Okay, we have 4 here: nickel, rubidium, gold, and copper. Okay, so properties of metals. Metals appears to the left of the dark zigzag line on the periodic table. Most metals are solid at room temperature, right? So, of course, there is a lot of metals in the periodic table. Metals, for example, have luster. This means that they are shiny. Look at the cesium, shiny. Ductile, okay? Metals can be drawn into wire, okay? That's the process's name, ductile. Malleable is the metals can be hammered into sheets. Metals have a high melting point. They are also very dense. Conductors, yeah, conductors, very good conductors of electricity and heat. A chemical property of metal is its reaction with water and oxygen. This results in corrosion and rust. Non-metals like sulfur, nitrogen, selenium, bromine. The properties of non-metal. Okay, one moment. I will go back some slices. Okay, the non-metals, the non-metals are on the right of the dark zigzag line. Those who are in the grass green color, for example, that will be the non-metals. Okay, I forgot to put on the slides here. Okay, non-metals. They also have a low melting point. This is why they are poor conductors of heat and electricity. So remember, metals, excellent conduction of heat and electricity, but non-metals, yeah, sorry, they are poor conductors of heat and electricity. Non-metals have low density. Brittle, okay, non-metals are brittle, so they break easily. This means non-metals are not ductile or malleable, phosphorus, for example. Non-metals do not have luster. They are dull. And metalloids like germanium, silicon, polonium, or arsenic, metalloids can be found clustered around the dark zigzag line that separates metals and non-metals, okay? So on the left of the dark side of the dark zigzag line, we have metals. On the right, we will find non-metals. And clustered around the dark zigzag line, we will find metalloids. If we talk about the properties of metalloids, so metalloids have properties of both metals and non-metals. The metalloids are solids that can be shiny or dull. Look at this, antimony or silicon. Yeah, shiny, dull. They conduct electricity and heat better than non-metals, but not as well as metals. And properties of the metalloids is that are malleable and ductile. For example, silicon. So the families on the periodic table, elements on the periodic table can be grouped into families based on their chemical properties. Each family has a specific name to differentiate it from the other families in the periodic table. Elements in each family react differently with other elements. So group number one, alkali metals, okay? The alkali metals is the first column on the left. And hydrogen is not a member, so it is a non-metal. Remember, hydrogen is not a metal. That's why, for example, in some periodic tables, hydrogen is not colored like all the entire column that he leaders. So for example, let's look at this. One moment. I am looking for, yeah, there it is. Okay, I will share with you what I'm seeing. Look at this. For example, the periodic table, okay? Here, if we look the first column, hydrogen is not a dark blue color. It's not colored by the dark blue. It is orange. Yeah, because it's a non-metal. Okay, non-metal in this periodic table have orange color, grass green color, and dark green color. That is non-metals. Metalloids are on red color, and metals that we can find in this periodic table are the dark blue column, yellow, all the sky blue color in the center, and purple, okay? Ah, of course, and two last row of rare earth elements, okay? So everything that is on the left of the red colored elements are metals. And hydrogen is non-metal and is not an alkali metal, of course. So alkali metal will be lithium, sodium, potassium, rubidium, cesium, and francium on the first column, right? Very good. That will be the alkali metal. One electron in the outer shell. I will talk about this on the What is an outer shell? Okay, soft and silver metals, very reactive with water, especially potassium, okay, and conduct electricity. The alkaline earth metal will be group number 2. Of course, will have 2 electrons in the outer shell, white and malleable, reactive, but less than alkali metals, and conduct electricity. Then we have the transition metals, okay? So we can find groups in the middle, good conductors of heat and electricity. Some are used for jewelry, okay? Jewelry, and the transition metals are able to put up to 32 electrons in their second to last shell, okay? Shell, I will do a spoiler here, okay? Shell is like different routes that the electrons can have orbiting or going around the nucleus. And of course, each of these shell or roots for the electron are quantized, yeah? So will be the route, the traffic route for electrons to going around the nucleus. Yeah, I will explain that when I finish all groups. I will explain with more detail the shells, okay? And can bond with many elements in a variety of shapes, okay? Boron family, 3 electrons in the outer shell. Most are metals, and boron is a metallite. Group 4, 4 elements, 4 electrons in the outer shell, contains metals, metallites, and non-metals. For example, the carbon. Nitrogen family, 5 electrons in the outer shell, can share electrons to form compounds, contain metals, metallites, and non-metals. The oxygen family, okay, very reactive, with 6 electrons in the outer shell. The halogens, okay, we have 7 electrons in the outer shell. All are non-metals, okay, and they're very reactive. We often bonded with elements from group number 1, the alkali, okay, very reactive. And the noble gases, okay. Hey, look at this. Every single element in the periodic table wants to be like a noble gas, okay? Why? Okay, because noble gases have an incredible stability, energetic and electronic stability, okay? That's the reason why all elements on the periodic table wants to be like a noble gas, because noble gases have 8 electrons in the outer shell, and that means that it's full, okay? Noble gases cannot give or take electrons from the environment, okay? Non-reactive with other elements. Hey, look at this, not reactive, okay? Not reactive. And the rare earth metals, okay, some are radioactive. The rare earth are silver, silvery white, or gray metals, okay, and conduct electricity. Oh, so the shells, okay. When you look at the periodic table of the elements, the energy levels of the atoms correspond to the rows of the table. The two elements in the top row, hydrogen and helium, are feeling their first energy level. Okay, so a shell is an energy level. Okay, the 8 elements of the second row are feeling their second energy level, and it is the outermost electrons that determine the chemical properties of the element. In looking at the diagram of an atom, note that the nucleus is fairly centrally located. The energy levels are built up from the level closest to the nucleus outward. Okay, this process of filling in the electrons from the first lowest energy level to the second slightly higher energy level to the third. Even higher energy level is called filling the electrons in by the Aufbau principle. Okay, the Aufbau principle is very stated. Is start at the lowest energy level and build up to the higher energy levels only after the lowest are filled. It's like a building, okay? It's like a building. You start with the lowest energy level, with the first floor, and we'll finish with the higher energy level that will be the last floor of that building, okay? And each energy level or shell has its own capacity, okay? So for the first energy level, can hold a maximum of 2 electrons in one orbital. The second energy level can hold a maximum of 8 electrons, total distributed over 4 different orbitals, okay? 4 different orbitals at the building will be like, okay, orbitals are the rooms, okay, and electrons, people, okay? So we have 4 rooms and 1 floor, and we have 8 persons or 8 people to collocated on different rooms, right? And the third energy level can hold a maximum of 18 electrons distributed, over 9 different orbitals. Okay, so the same. We have 18 different persons, only 9 rooms in the entire floor. Okay, so you have to put on each person and a different room. Okay, so I talk about this, the periodicity, right? Okay, is the tendency to show a regular repeating pattern. That will be periodicity. That will be a question in your exam, for example. Okay, and the atomic number of an element is equal to the number of protons in the nuclei of its atom. Okay, but I will talk about this on next video. I will end this video right now, and we're going to talk about the quantity of electrons, protons, and neutrons on a neutral atom, for example. Okay, so goodbye.